So it's a little noisy in here. I just got back in my back garage and it's like in the teens outside, so my heater's running to get my garage up to temp. But this is the Ford chassis harness for my Challenger. I've already integrated the Mopar Performance Controls harness into, so it looks like one big harness. It's a little cleaner that way. If you've been watching my other videos, you'll see that I built a bench programming module to be able to change programmable settings in the Hellcrate PCM with what I'm going to use as HP tuners and their MPVI 2 Plus cable. So the reason I'm doing that, I really don't want to put any radical tunes or anything in this out of the gate, but what I want to do is reconfigure the cooling fan settings. So the late model Gen 3 Hemis use what's called a GPEC 2 controller, and from the factory, that one controller, based on programmable parameters in software, can control a number of different fan setups. So some vehicles use a 2-speed single fan, some vehicles use a dual fan 3-speed setup. The factory Hellcats use a brushless, pulse width modulated controlled single fan setup. It's like $1,300. I thought about potentially using that because I'm sure it moves a ton of air, but even if I could reconfigure the harness and the ECM to use that, I'd still be stuck with how do I turn the fan on when I use the air conditioning, and that's really the biggest issue I have. So Vintage Air and all the aftermarket setups use a simple binary or trinary switch that closes when the pressures are within a certain range to turn on the compressor clutch, and then you generally turn your fan on at that point too. Trinary switch will go a step further. If the pressures get too high, it'll kick on another fan, which in my previous application was the high speed mode of a Lincoln Mark 8 fan, which I'm going to attempt to run. If I use a pulse width modulated fan, the ECM has to turn it on and off. So even though the GPEC 2 controllers do control the AC compressor clutch in a factory setting, those compressor clutches are generally variable displacement. And even if I could turn it to on-off, I still have the issue that I don't have a 5 volts AC pressure sensor. I have a simple binary trinary switch, so it's not going to work. I can't get this ECM to properly control an aftermarket AC compressor clutch. So that kind of makes the factory Hellcat fan, I just can't use it. So I don't know if it's going to fit yet. It's going to be really close because it's a beast of a fan, but I'm going to be running a 4-core Frostbite radiator with a Lincoln Mark 8 fan that's been trimmed down. It's a beast, high-powered fan. It's big. It has 2 speeds. So why I'm doing all this programming is I'm going to try to switch this over to a single fan 2-speed mode in the ECM, and then I have to add a circuit. So the Hellcrate harness is set up to control only one fan, one set temperature, through a simple relay in this power distribution module. So there's only one circuit. I'm in the process of adding the second low-speed circuit that's used in all the other non-PWM fan applications. So once that's installed, I should be able to control my 2-speed fan. So the way that's going to work is I'll have one temp setting for low speed, one temp setting for high speed, obviously, in the ECM. Anytime the AC is on, the trinary switch will send power to low-speed fans to kick them on, because you always need airflow moving through the condenser. If pressures get too high, I have another circuit wired up that will kick on the high-speed fans via relays. And then I also have a fan override switch in the dash. I'm using the factory rear defogger switch to kick on the high speed if I want to cool it down in between passes or for any other reason. So yeah, so this is a little complicated the way I have it wired up. So I'm still using the relay in here. This will control my high speed. I just added this relay with the sealed kit here. This will control my low speed. So the low and high speed outputs from the ECM are ground controls. Everything on my fan control side, unfortunately, is power, and I could flip-flop it back and forth, but I'm still going to have to convert it some way. So these relays are really just going to be used to convert the low current ground signal from the PCM to a low current 12 volts positive signal. Again, I could have reconfigured all my existing relay setup that I had for my previous build and to work with the vintage air setup and everything to ground triggers. But there's one other reason I decided to have these 2 relays still in place. They're going to last forever. I mean, they're going to be triggering milliamps, so even though there's added complexity, the reality is these will last forever. But the reason it's still good to have these relays here is it isolates the ECM trigger circuits from voltage feedback. So because I'm using multiple things to trigger the low and high speed settings on these fans, I'm not sure how this ECM would react to being backfed ground when the drivers are shut off. There's a possibility it could damage them, so I don't want to take that risk. Having these relays here is just good insurance to ensure that when the ECM is not commanding these 2 relays on, there's no way for any other voltage or ground signals to go backwards into the ECM and fry one of my drivers. So that's why I'm doing that. The Lincoln Mark 8 fan draws a ton of current on startup, even on low speed. So what I have is I have 2 mini or micro 280 relays in this power distribution module that I built that are actually going to trigger 2 separate cooling fan solenoids that will actually bear the brunt of the current. So they're really just, I have relays triggering relays, triggering massive continuous duty solenoids, and those solenoids are really up to the task of handling that high current. They do sell high current relays, but with the Lincoln Mark 8s, it's spotty whether or not they'll hold up. The solenoids I bought are rated at 100 amps each, so they'll definitely withstand it. I've ran that same set for a few years already with my previous build. So that's kind of the method behind the madness. It sounds complicated. It really isn't. And like I said, there's reasons I'm doing it the way I'm doing it. I want to have multiple speeds because you don't want to start one of these fans off at high speed. That's the other thing people will try to do, is say, well, I'll just make it simple and just run high speed. Well, the inrush current is so high, it puts a huge strain on the relays or solenoids that you're using to power it. It's not good for the fan motor, and it's hell on the charging system too. So I have these wired up in a way where the high speed will never be able to turn on unless the low speed is turned on first. So that smooths that current spike. And both circuits cannot be actuated at the same time, because that's also a bad scenario. You don't want the low and high circuits actuated in the motor at the same time. It'll actually slow down the fan and cause it to overheat. So that's how I have it set up. There's tons of other ways to do this, but I'm kind of finicky when it comes to certain things, and cooling is definitely one of them. I don't want to have any issues, and I want to just kind of operate like a factory setup. So that's what we're doing.